Hello and good day to everyone. My name is Syafiq Kasmazuli and my matrix number is AE100107. And now I will show you the simulation on activity 1 for lab 9, which is AC voltage measurement using oscilloscopes. So in this experiment, we are going to figure the graph for the AC voltage for AC voltage source, the graph of the voltage for resistor 1s, and the graph of the voltage for variable resistor 1 here. For your information, our AC voltage source, we use 14.6 volts and our frequency is 50 Hz. For R1, we use 100 ohms, and for our variable R1, we use 1000 ohms. And now I will run the simulation first. Then after we run the simulation, I will click the oscilloscope here to see the graph. So this is the graph for the graph of the voltage for the three VAC supply, VR1 and variable resistor ones. So here is so you can see here for the VAC ones, voltage of the source. Here is the yellow one is referred to the voltage of the source. We can see here the maximums, the minimums, and the RMS value. Meanwhile, for the voltage of the R1s, it is referred to the blue graph. Here we can see all the maximums, the minimums, and the RMS value here also. And meanwhile, for the voltage of the variable resistor 1, it is referred to the red graph. So here is maximums, minimums, and RMS value. And now I will try to zoom in the graph first. So here is the it is how the graph looks when we are zoom in the graph. So you can see that our maximum is 1.327. So example for the voltage of the variable resistor ones. So the maximum is 13.27. This is the maximum amplitude and the minimum amplitude here. So from the graph, we can figure out the value of the maximums, minimums, median, mean, and RMS. So next, this is the graph of the manual way to draw the graph. So this is the basic supply here, and we get our Vmax, Vmins, Vpk, VRMS, period, and frequency. This is the voltage graph for variable resistor ones. This is the graph. And also this is the voltage graph for the voltage R1. Here also we get the Vmax, Vmins, Vpk, and VRMS. So that's all for me. Thank you.
Okay, hello, my name is Zaim Mazlan and my matrix number is AE190070, and now I'm going to present about the activity 3, which is the equation. So for the first one, we need to using the equation for P equals to VI cos theta to calculate and record the power dissipate by the circuit. So first we need to find the R. So R is a series plus 100 ohm with 1 kilo ohms. We got this value, and then find the I. Divided 14.6 by 1100 ohms, and then after get the two value, put into this equation here to get the power. So the power is equal to 0.1937 watt. Next is using the equation P equal to V square over R. So same thing, just put the value, and then we get 2.13 watt. And next, we need to using the equation is P equal to I square R to calculate and record the power dissipated by the resistor R1. So using the R1 load, 100 ohms, and I value, then we get the power is equal to 0.0176 watt. So for the fourth question is, do all power values agree? Then the answer is yes. And next, for the conclusion part, from this lab, we use the oscilloscope to measure the AC voltage of several simple circuit, and the oscilloscope let us actually see the voltage going through our setup and allow us to manipulate it to acquire value and a different perspective of this flowing energy. So through this lab, we slowly figure out on how to properly use this machine and how each of it affect the output of the live graph. And that's all for me. Thank you.